Okay, so we are continuing our 4.5 and 4.6a, so our introductory piece for those lessons. We're going to start talking through the irrational conjugates theorem. So we're going to go through two problems. One problem I am going to go through completely, not really pausing, but just a fluid working through that problem, showing you my process for that. So I do that one in red. Okay, red for you should be an indicator that you're going to kind of stop, watch, and listen type of thing. Then we're going to go through one that is blue. That blue one is a problem for us to go through together in a sense. So when I work through in blue, I'm going to take pauses because I want you to try to think through, anticipate my answer basically, and a way for you to see what you would do and then see what I would do from there. Okay, so irrational conjugates theorem. So if you have a polynomial function, rational coefficients, all that good stuff, then if you have a plus root b as a 0, then you also have a minus root b as a 0. All right, so if you are asked to write a polynomial of least degree with rational coefficients and a leading coefficient of 1, and that function has zeros at 3 and at 2 plus root 5. So leading coefficient of 1 means that when written in standard form, that a value, that leading coefficient, should be 1. So we're not adding an additional factor outside. We should end with an equation with the 1 as its lead coefficient. If you end with a different coefficient in the lead, you did something a little bit wrong. You need to go through and check your process. All right, so zeros at 3 and 2 plus root 5. So that 2 plus root 5, that's one term. That's not two different pieces. That is one piece of information. So this is how I work through this process. I'm going to make a list of zeros. So these are the zeros. Zeros meaning the value that if you substitute them in for x, the output of your function would be 0. Zeros meaning your x-intercepts if you were to place this function on a graph. So I have zeros at 3, and I'm given a 0 at 2 plus root 5. So at this point, I need to think about what I'm working on. So I'm working on the irrational conjugates theorem. The irrational conjugates theorem should stop me at this point and go, oh, I have an irrational 0, 2 plus root 5. If I have that 0, I must also have another 0 at 2 minus root 5 due to the irrational conjugates theorem, due to the process and information found in that quadratic formula, right? That plus or minus piece in there. Right, so once you make your list of zeros, what do zeros represent? Well, the x values that would cause a 0 in your function, your x-intercepts, and we use those values to write out factors. So if I have a 0 at 3, what factor would that create? It would create an x minus 3 factor. Because if I substitute 3 in there, 3 minus 3 would give you a 0. So when I have my 2 plus root 5, it looks like this. It looks a little wonky at first, but we'll simplify it out. So you have x minus 2 plus root 5. And again, because of that conjugates theorem, x minus 2 minus root 5. So I want to take those and those double brackets, right? They'll cause an issue later if we accidentally forget them. So we're going to simplify those right now. So if I distribute that negative, this factor would look like x minus 2 minus root 5. And this factor would look like x minus 2 plus root 5. Still following that conjugates theorem. You see the same factor minus root 5, same factor plus root 5. So still following that same pattern. The whole point of taking those zeros and changing them into factors is it allows us to write our function in factored form. Okay, so we're going to write factored form of a function. So f of x equals x minus 3 times x minus 2 minus root 5 times x minus 2 plus root 5. So if I need to write a polynomial of least degree, it's a fancy way of saying I would like you to have this simplified all the way into standard form. So standard form means I need to take those factors, I need to begin distributing them. So when you need to distribute these, typically we would go left to right, but because of the uniqueness of having those irrationals, it's actually fastest to distribute the irrational factors first. So we are still representing f of x. We are not going to use our x minus 3 just yet, so we're going to keep that. And we're going to begin distributing the other terms. So I have x times x, so I have x squared. I have x times negative 2 minus 2x. I have x times root 5. So this is going to be plus x root 5. I'm going to take that negative 2 now times x, so negative 2x, negative 2 times negative 2 plus 4, negative 2 times root 5, so minus 2 root 5. Right? I still need to deal with that negative root 5, so we're going to have to be careful with that because it does a little thing at the end. So negative root 5 times x is negative x root 5. Negative root 5 times negative 2, so that is positive 2 root 5. And this is what I was talking about right here. What do you get if you have root 5 times root 5? Right, that's like the square root of 5 squared, so it actually turns into a 5. I have a negative times a positive, so I have negative 5. Because if I have the negative root of 5 times a positive root 5, I have the negative of root 5 squared. Well, the square root of 5 squared is 5. So, really long, but each of these get really short very quick. So that irrational conjugates theorem, saying that we have a positive and a negative of each of those irrationals, means in here we should see that same pattern. Look at that, a positive x root 5 and a negative x root 5. Those zero out. A negative 2 root 5, a positive 2 root 5. Those also zero out. So we are left with x minus 3 times x squared minus, I have x's I can combine, so 4x. And I have whole numbers I can combine. 4 minus 5 is negative 1. So it gets really, really long, and then it gets really, really short. I need to continue to distribute. Okay, I still have two sets of parentheses. So x times x squared is x cubed. x times negative 4x is negative 4x squared. X times negative 1 is negative 1x. Negative 3 times x squared, negative 3x squared. Negative 3 times negative 4x, positive 12x. Negative 3 times negative 1, positive 3. And always see if you can simplify that down. So f of x equals, alright, I have an x cubed. Here are my squares, so negative 7x squared. Here are my x's, so plus 11x, and my whole number of 3. Alright, you have to go back up to the instructions. Let's make sure we did what they asked us. Did we write a polynomial? Are there multiple terms? Yes. Of least degree, so standard form 3, 2, 1, 0. Yes. Rational coefficients? Absolutely. Leading coefficient of 1. So in front of this x cubed, yep, there's only one of them. And did we utilize all of our zeros? Yes. We have 1, 2, 3 zeros. So our highest degree should be x cubed. Alright, so we double checked. What should be true? Done. Alright, so let's try one. We're going to go a little bit slower because I want you to try this one. So I'm going to do the whole thing, but I will be taking pauses so that you can try it. So get a piece of scratch paper or something so that you can do this one on your, well, on your own / with me. All right. So, again, we are writing a polynomial of least degree with rational coefficients. We need a leading coefficient of 1 and zeros at 2 and 3 plus root 7. So, what is the first thing you need to do? All right, let's make our list of zeros. So we have zeros at 2 and a 0 at 3 plus root 7. If we have zeros at 2 and 3 plus root 7, what else do we know? Alright, that irrational conjugates theorem tells us that we also have another root. That other root being 3 minus root 7. So we have 3 zeros. What do we make with those zeros? You should make them into factors. Alright, so what are those 3 factors? You should have x minus 2. You should have x minus, it's always x minus because we're making zeros, 3 plus root 7, x minus 3 minus root 7, and we need to simplify those.